All right. Hey, how's everybody doing today? Can everybody hear me all right? Just let me know in the chat box if you can hear me right now. Okay, sweet. All right, don't want to waste any more time, so I'm going to go ahead and get started. So today we're going to be talking more in detail about the atomic orbitals, which I referenced last time. But before we do that, I wanted to, first of all, introduce you to some useful programs that will serve you well as you study organic chemistry. They make it easy to learn about structures first and foremost because they automate a lot of the common structural things we do. So Marvin Sketch, which I can actually pull up right here, is a program that you can use to draw structures that will automatically take into account things like valence and whatnot. So for instance, if I draw a single bond there, you can see it automatically adds in carbons and the proper number of hydrogens, and then if I add yet another bond, it takes hydrogens away and sort of automatically accounts for what an organic chemist would be drawing anyway if he were drawing on paper. One thing I wanted to do today, and I'll do in a second, is show you how to sort of draw the shortcuts that organic chemists use in representing structures. And you're going to see these shortcuts again and again, so you should get used to what they mean now so that when you see them later you're not confused as to what's going on. Right, so Marvin Sketch is one program that comes in handy just for basic structure drawing. And then to look at stuff in 3D, really JMOL is a great program. And I won't demo JMOL for now in the interest of time, but you can load structures into JMOL and rotate them and translate them in 3 dimensions to really get a good idea of molecular structure in 3 dimensions. So using those, perhaps even as you follow along with the lectures, may come in handy. All right, so let's get on to a quick review here of what we covered last time. So last time I talked about the language of organic chemistry as Lewis structures. And today what I wanted to do was review that in the context of some of the shortcuts that chemists use. So for instance, we learned that 2 electrons are represented in a bond by a single line. A lot of the times you won't see chemists draw the atoms out explicitly. Of course, I said that if you see a letter on a Lewis structure, obviously that means an atom, but that's not always drawn. So take, for instance, propane, which the full Lewis structure is this guy right here. Most chemists would draw this one of 2 ways, either simply like this, or with the methyl groups on the end like this and drawing that inner carbon with no hydrogens on it. Anywhere where you see a vertex in an organic structure or just an open line, recognize that that means a carbon with the correct number of hydrogens attached to get it up to its valence. So for instance, carbon has a valence of 4 with 1 bond attached. We know that there are 3 more hydrogens here. So these 2 representations as well as this one are all equivalent, and this is a shortcut that you'll see over and over again. However, we don't do the same for heteroatoms. So heteroatoms are nitrogen, oxygen, sulfur, anything that's not carbon or hydrogen. We always draw the hydrogens on heteroatoms. So for instance, this is a thiol. You'd never see anything like this where a chemist would expect you to fill in hydrogens on that sulfur there. Another shortcut you'll often see is that chemists will leave out lone pairs. For instance, ethers will often be drawn just like so, without the oxygen lone pairs. Of course, we know the lone pairs are there, but we don't necessarily have to draw those, and it's understood that unless there's a plus or a minus drawn on the oxygen, it's understood that that oxygen has an octet of electrons, and being neutral, we would expect it to have 2 lone pairs there. Alright, so that's a little review of the Lewis structures. Wanted to talk now about the atomic orbitals in a little more detail. So we learned last time that the 4 atomic orbitals are the 2s, the 4 valence orbitals, I should say, the 2s, the 2px, y, and z, where I just kind of arbitrarily made up those directions, are the atomic orbitals. And we're going to get into a little bit what it means to combine the atomic orbitals in the context of forming bonds. So atoms possess electrons that are in orbitals, and we combine those orbitals to form the orbitals of molecules, which tell us where electrons are in molecules, which is of course pretty critical. One thing I wanted to mention too is the idea of the orbital diagram really quick. So the way I talk in the wiki text about the difference between the energy of an orbital and its shape. So these are the shapes of the orbitals I've drawn for you here. Actually, let me jump to the big slideshow so y'all aren't seeing my entire desktop the entire time here. Oops.